So before we introduce the new notation, let's remind ourselves of the fundamental theorem of calculus part 2. The integral from a to b f of x dx is, it was big F of b minus big F of a. And now the new notation, we can write this as big F of x with a vertical bar next to it from a to b, which literally means take the b, plug it into whatever function this is, then take the a, plug it into whatever function this is, and subtract the two answers. So it exactly means this thing. You will also see this written as big F of x with a square bracket at the end, or big F of x with a square bracket at the end and a square bracket at the beginning to try to help group things. But what you probably won't see it written as is a vertical bar at the end and a vertical bar at the beginning, because that would be like absolute value, and we are not doing absolute value here. All right, so from our previous video, we had the integral from 2 to 5 x squared dx. We said big F of x equals 1/3 x cubed, and then we wrote this as big F of 5 minus big F of 2. So that's true, and that's actually a nice way to do it, because then you get to see the antiderivative function in Desmos if you're plotting it. But now we know we can also write it as big F of x vertical bar from 2 to 5, or we could write it as 1/3 x cubed vertical bar from 2 to 5. And if you saw that on the paper, you would do 1/3 5 cubed minus 1/3 2 cubed. All right, so let's practice another one. How about the integral from -1 to 0 x cubed? So it wouldn't hurt to draw it, right? From -1 to 0, what does x squared look like? It's that part of a parabola. What can we say for upper bound, lower bound, and guess? Lower bound of 0. We can't really get a better lower bound because it's just all along the axis there. Upper bound would go like that. A height of 1 times a width of, what do you think? Does that have a negative width? Well, its width is 0 minus the ending point 0 minus the starting point -1. So it's 0 minus -1, which altogether is +1. And then our guess would be the lower bound plus the upper bound over 2, and that would look like this. And again, can you kind of figure out whether the guess is going to be a little too high, a little too low? Think about area that we're accidentally including that we don't mean to be including. Think about area that we should be including that we're not including, and which of those seems larger. So now we'll do the antiderivatives. So we know the antiderivative of x squared, oh, I forgot the dx, is 1/3 x cubed. And then we can just write the starting at -1 going to 0. And so that's 1/3 0 cubed minus 1/3 -1 cubed. 1/3 0 cubed is 0. The -1 cubed is still -1, so we get 0 minus 1/3, or +1/3. Does that work with our lower bound? Yeah, it's above our lower bound. Does it work with our upper bound? Our upper bound was 1. Yep. And our guess, well, our guess was a half. We got a third. Close enough. And we saw that the guess was actually larger than the true value, right? The guess was a half. The true value was a third. and the guess was larger than the true. So next we'll talk about integrating sine.